Hi, I'm Gary, and I want to show you how I use Cloudy. Okay, we've got the download. We've had a look inside the tarball. We've looked at the documentation. Now let's build the code. To do that, we've got to get a compiler that we trust. There are two cases most astronomers will fall into, either a Mac or Ubuntu. There are instructions for getting compilers on each. Let's use Mac because that's what I have here. And I'm going to use the Apple command line tools to get a copy of the compiler LLVM together with the associated tools. So you can download this, Google on install Apple command line tools, and you'll find lots of help. And if you're on Ubuntu, you can use LLVM or GCC. On Mac, you can also use GCC on a Mac if you install it with Homebrew. So now we've got two compilers available, and we've installed one of them on our computer. Now let's have a look at the directory structure that we've been working with. And we see the second to bottom folder says source. So inside source is the C++ source code, this .cpp and .h files. And then there's a number of other files in source directory as well. We're going to use the GNU make utility to build a working executable. So beneath source is a number of folders. This is a very, very simplified schematic of what's in source. We're going to pay attention to two folders in particular, sysgcc, which is the folder we're going to use to build Cloudy if we want to use GCC, and then the LLVM, the syslvm folder, if we want to use the LLVM compiler. So it's your choice. We can use either one. If you look inside these folders before doing anything, the source folder has lots of files, very confusing. But if you look inside one of these sys files, there's only going to be a tiny handful of files, which are the makefile configuration files in order to use make. So what we're going to do is open a terminal, cd down into source, and then I'm going to do sys LLVM, and then we need to use the GNU make command. The simplest case, you just type make, go get a cup of coffee, and when you're done, you should have a working Cloudy, or better, it'll be a little bit faster if you use the -j command to tell make to use more than one core. This Mac has 8 cores, so I'm going to do make -j8, telling it to build Cloudy using all 8 cores. To speed things up a little bit more, if we don't have to look at all the terminal output that happens as make progresses. And so the caret dev null sends the output to device null, which is a polite name for the black hole that's included on all Unix computers. So we'll do that. We'll do that next in a terminal. As it builds, we're going to watch for errors. So here's our command prompt. I've done a directory listing. We're inside the download. You can see the files and directories we've talked about so far. Our interest today in building the code is going to be the source directory, the second from the bottom. So let's change directory into source. If we do a listing of what's here, you find a very, very large number of .cpp and .h files. So this is the Cloudy C++ source. There's several directories underneath. The one we're interested are the ones that start with sys. And on this computer, we're going to use LLVM. So I will change directory into sys LLVM, and we find a much, much emptier directory. It won't be empty for very long. So this shows the three files, this README file, the two makefile files that are needed by GNU make in order to understand how to create a working Cloudy executable, given the information we have. I'm going to use LLVM to be a little bit on your toes. You got to remember LLVM compiler is not called that. It's called Clang++. And so what I'm going to do is just to demonstrate, I'm going to use the shell which command to identify the version of Clang that is in use. So there it is. That's installed by Apple. And we can, just as a check, to see that it works at all, check its version. So there's the Clang version. Um, what we're going to do now is use the GNU make command and uh, build Cloudy. Now I want to use all 8 cores, so I'm going to type minus J8. It doesn't quite get you a factor of 8 in speed, but I speed things up quite a bit. And I'm going to pipe the output into device null so it doesn't hit us in the screen. So I'm going to hit enter. Now, okay, it's finished. Now let's look. Remember, we had a empty directory before. Now it's filled with object files. And we can also see that there's 2 executables. I'm doing ls on star.exe. We're interested in cloudy.exe. And what we want to do is make sure that it kind of works. And this is what is called the smoke test in engineering. In electrical engineering, if you build a new apparatus, the first test you do is plug it in the wall and make sure smoke does not come out. So we're going to run a test that's just about at that level and make sure that Cloudy works in some way. And we're going to do it in a simple way. In Unix, we have an executable called cloudy.exe. And as a defense against Trojan horse attacks, there's a rule that you have to explicitly write out the path to your executable by explicit location. So in this case, it's a dot backslash, and then we have cloudy.exe. So Cloudy, that's going to execute Cloudy, it's going to use the input from the terminal for the commands, and then it's going to produce the output also to the terminal. So we'll see tons of stuff happening. So now Cloudy is waiting for command input. The smoke test has a simple command. It's the word test, and I'll hit enter. This time is Cloudy. It takes a minute because it's got to load all the atomic data to set up a calculation. Okay, that took a minute. It takes a while to load all that data. What we're interested in, it did do a model, a very simple model. We're interested in this last line right here. It says Cloudy exited OK. So that means, at least for this test, you have a working Cloudy executable. So I want to summarize really quickly how it is we did that in the next screen.